right, so here it's asking us to integrate 1 over x squared minus 1. So this seems like it should be an integration by parts problem because the coefficient on the denominator is greater than what's on the numerator. So this seems like it's integration by parts. So let's get to it. The first thing I want to do is break down this x squared minus 1 into something simpler. And I can see that this is a difference of squares, so let's break down x squared minus 1 into x minus 1 and x plus 1. Boom. Now let's rewrite this integral. So this is basically equal to the integral of 1 over x minus 1, x plus 1. Now I want to simplify what's inside of this box, blue box here. And in order to do that, let's follow the rules for partial fractions. So let's just take whatever's inside this integral and simplify it. So I have 1 over x minus 1, x plus 1, right? And I can rewrite this equal to a over my x minus 1 and plus b over x plus 1. All right, so now to get rid of my denominators in this case, I'm just going to multiply this x plus 1 over here and this x minus 1 over for this b. So let's get to it. So 1 is going to be equal to a times x plus 1 plus b times x minus 1. All right, so now we're just going to have to find these variables. Now the best way to do this in this special case over here is to actually set one of them to become 0. All right, so in this case, if I plug in 1 here, right, this will be set to 0 and I can figure out my a. All right, so let's do that. I'm going to put this in blue, set x equal to 1, so this entire chunk becomes 0. Okay, so let's do that. So 1 is going to be equal to this thing becomes 0, and it'll just be a times 1 plus 1. Alrighty. So we'd get right? Because we'd have 2a over here and we just bring it down here. So we'd get half is equal to a. So we found our first number. Now to find our second number, we're just going to let our x become equal to negative 1, right? So 1 is going to be equal to a negative 1, and 1 will cancel out. So my a is going to become 0 in this case, right? So it's going to be 0 plus b times negative 2. So basically, it's going to be negative half is equal to b when we do the algebra here. So now we found both of our values that are needed to plug back into this. So now I can rewrite this, right? Our 1 over, I'm going to write this in green. So if I have 1 over x minus 1, oopsies, x minus 1, x plus 1. This is basically equivalent to a value of, what's our value of a? Half, so it's going to be half over x minus 1 plus b, which is negative half over x plus 1. So how are we going to simplify this over here? Let's actually integrate this one. Okay, so let's integrate. I'm going to put this in red, this. All right, so we're going to be taking the integral of half over x minus 1 plus negative half over x plus 1. Okay, so the first thing that's going to be happening is I forgot my dx here, it's essential. We're taking the integral. So I'm going to take my half out, right? As simple as that. So it's going to become half, and we're going to take the integral of these individually because we have a plus sign. So it's going to be half, we're going to have dx over x minus 1 minus half, and we're going to have dx over x plus 1, like so. And what are we going to do now? We're going to understand this essential thing, especially when we're with partial fractions. This little simple formula, this trick, right, is really essential. To solve these integrals, we have to use u substitution, but many teachers want you to know this off the top of your head, and you won't have to show you substitution in this case, just use this formula. So if I have the integral of dx, right, over a value of x minus a, right, it'll basically be equal to the natural log of x minus a. But remember, it's mod. It's mod of whatever's inside x minus a. So it has to be positive. All right, so let's do this. Let's just implement that so this question gets done over with very quickly. So this is going to be equal to half natural log of x minus 1 subtract half natural log of x plus 1 mod plus c. So this should be our final answer to this question. Hope it helped. Have a good day.